Hi, welcome to In 5 Minutes. Again, an university problem from Mumbai University, May 2015. The problem is for 10 mark. We start with our analysis. We find the type of the transistor. We can say N or P. Always the arrow is from P to N. So it is NPN type of transistor. So identify the terminals. This becomes your emitter, base and collector. Input is applied to base, output we are taking from collector. So it is NPN, common emitter, BJT. Which type of biasing? You can say we are taking the biasing from the fixed voltage 20 volts. So it is fixed biasing type circuit. So what they have asked, they have to tell you to find ZI, ZO and voltage gain. So for DC analysis, what we have done for fixed biasing, the same steps will be followed over here, right? So this is the minor change. Usually you get voltage divider type you get usually, but what they have made a simple change is instead of giving voltage divider biasing, they have given you fixed biasing in the DC analysis. So we'll start our analysis. What we do, we draw the circuit under DC operating conditions. So for that, what we do, we remove all AC sources and open circuit all capacitors. Now looking at the diagram, we'll remove this capacitor, that it will be open circuited, this capacitor open circuited, and we are left with only the remaining part. So how the circuit will look like this under DC operating conditions? So for that, what we do, we apply KVL to base emitter loop, the loop in which we have VBE. So this loop will apply KVL. So what will be the equation? Shortcut again, IBQ equals to 20 minus VBE. This volt we are living with positive sign, we are living with negative sign, hence negative, divided by the total resistor. You can say 470 kilo ohms plus 1 plus beta times 0.56 kilo ohms. VBE if not given, we take it as 0.7. So you will get IBQ as 35.88 microampere. Once you know the value of IBQ, can find the value of ICQ, which is beta times IBQ. So you will get ICQ as 4.306 milliampere. Once you know ICQ, you can find R pi, which is beta times VT upon ICQ. Beta given in the equation is 120, VT 26 millivolts constant, and ICQ we take it as 4.306 into 10 raised to minus 3. So this will give you R pi as 724.57 ohms. Once you know R pi, you can find GM as ICQ by VT, which will give you the value. What you will get is 0.165 ampere per volt, or you can say 165 milliampere per volt. Rather than writing this, you can keep it as 0.165 ampere per volt. Now we can find the value of RO, but since VA is not given, we will neglect RO. We will not consider Searle effect resistance RO in the AC analysis. So once we have done with the DC analysis, we go for the AC analysis.